into this explosion of interactions that puts demands on all of our environments that simply weren't there before. And so this role of interactions to transactions becomes really, really important. Now, let me carry this forward and see if I can make this a bit more of a real example, and I'm going to blend some fiction and nonfiction here. So let me start with a fictitious company that we're going to call Fitco. And let's assume that this company, Fitco, can build every type of wearable device and can do every kind of health monitoring that we would want as consumers. And they have to have an online portal, they have to maintain inventory, they have to have stylish goods, they have a whole bunch of employees that are serving needs, they've got an army of trainers that are customizing workout programs, so we can all think about that company. Now, I want to share something that actually happened, and I'm going to solicit the help of my Couchbase colleagues. So a couple months ago, we had our healthcare provider that provides benefits for the company, and we had a credit. And one of the things that we were determining as a leadership team is what do we do with that credit? Well, one of the things that we thought of is let's create a great program where employees can set health goals, and in return, we're going to get some devices that allow them to be more effectively in pursuit of those health goals. So for the Couchbase team in the audience, raise a hands on who's taking advantage of that program. Okay, so we have quite a few. Now we're going to test how much nonfiction and fiction there is. So the people that raise their hands, how many of you think you're doing a better job with your fitness goals than your colleagues? All right, so clearly have some people that are stretching their imagination. We've got a very imaginative employee back there. But this is where the experience starts to change. And one of the things that I somewhat made the mistake of is working with a few colleagues on sleep goals. So we all want to sleep better, and so whereas before I had kind of gotten to the behavior of, well, let me set my phone aside and try to get some sleep, and then as soon as I wake up, I run into the bathroom where I have my phone and start looking at email. Well, over the last several weeks, what I've done is run and loaded my application to see how well, or in this case, how poorly, I've been sleeping. Then I rush into the office and I'm literally, with the device and the application sitting there with other colleagues comparing, how much REM sleep do we get, right? And what I would do for an additional percentage so that I would feel better and also so that I could win the competition. Well, imagine what I would do if this imaginary company, Fitco, had a better device. Maybe it looked better. Maybe it fit me better when I was sleeping. Maybe the algorithm that calculated it would actually accurately say that I'm a better, more effective sleeper than the people that I'm working with. I would do anything to change my experience as would the other people. But the reality is to create that experience and meet my needs as a consumer and improve the experience that we all have requires a completely different approach to underlying infrastructure and specifically databases. So why do I take you all through that? If we were to look historically, and all of you know this pretty well, there were two types of databases. There was what we call the system of record or transactional databases, and there was what was referred to as a system of intelligence or analytical databases. Transactional databases ran fairly monolithic, slow, standard applications, and analytical databases allowed you to pose questions on the data that resided in there. But as we move into the modern world and we're experiencing the fourth industrial revolution, these legacy databases aren't sufficient. And with the explosion of all these interactions, a different approach was required. And that's why we at Couchbase have built the engagement database. And we have defined engagement as successfully managing interactions over time. And if I'm pleased with that relationship that I have with the digital provider, I'm engaged. I'm going to spend more money. I'm going to tell my friends about it. I'm going to be more productive at work. I'm going to encourage my employees to take advantage of applications. We're going to be more collaborative. Our business is going to be more successful. And in turn, the $24 million that we're spending to take advantage of the opportunity that business provides itself with this changing world will be successful with. Now, the reality of this approach is that with the engagement database that's focused on interactions, it affords us at Couchbase the flexibility with your input to determine how far we extend the platform. Do we take it in the direction of managing additional transactions, extending it from a system engagement to including more applications that blend engagement and system of record? Or do we blend it more in areas of analytics where we're allowing the platform to provide business insight in a more sophisticated way than would otherwise be the case? And as we get up here on stages like this and in breakout rooms and talk about our constant innovation, it's going to be in the context of this engagement database and how it relates to other legacy systems. Now, what we've done with that is we've built an integrated platform. And this integrated platform is built on the most powerful NoSQL engine in the industry. At the core of our architecture is an in-memory, shared nothing, scale-out approach to our database. And from the early days of building this, we had a philosophy that we could start to consolidate layers of what were previously distinct systems. This started in 2011 when we brought two companies together that brought an industry-leading cache together with an industry-leading document-oriented database. And the philosophy that's driven our development is to continue to integrate services in a common platform that you can take advantage of. We've extended our architecture out to the edge with our mobile capability and ensured that we had synchronization technologies and data movement technologies to enable that distributed data platform that you can take advantage of. We've then continued to add data access technologies that application developers and applications themselves can take advantage of this underlying very flexible data schema. Things like key value, indexing, our industry-leading query language that we call Nickel, which replicates SQL on top of JSON. We've added full-text search. But we've done all of that with the mindset of doing it as an integrated platform, continuously ensuring that it works together seamlessly, and you can take advantage of these services as you see fit and fitting them into your existing environments, but still changing the way the applications work and fundamentally, improving your business. One of the reasons that we've been so excited about Connect Silicon Valley is because we're announcing our latest service, analytics. And what we see happening right now is this explosion of data, but what companies need is not just a way to manage the data, but how do they derive more insight from it? How do they create business insight that gives them a competitive advantage? And I'm going to go through some examples in a minute, but succeeding in this digital revolution is not just about, okay, I've created an application. How do I create one that gives me competitive advantage, that allows me to better serve my customers, that makes me a more effective business than my competitors? And the reality is there's huge opportunity, but there's huge risk for companies that don't take advantage of this. And with that mindset in driving our philosophy, this was why we moved forward with analytics. And what analytics enables is us to do with your applications, deliver rich, real-time, actionable insights directly from operational data. We've built it in such a way that you can query data in its natural form. So this isn't about old days where you needed to transform data and spend a lot of time and money to do so. Query it in its natural form. And one of the big breakthroughs, which you're going to be hearing about more, is our ability to run ad hoc queries without slowing down application performance. So derive insight directly from your operational data without the overhead of changing anything, without slowing things down. And when Ravi and the team get up here in a moment, you're going to get more details on how simply this is to deploy and use and take advantage of. Okay, so we've talked a lot about the platform. You're hearing a lot of kind of general capabilities. But what I wanted to do now is put into context how you can better leverage Couchbase, or how you can think about unlocking the value that we've provided. And at the foundation of this is our data platform. And we believe we have the highest performing, most available, easiest to manage secure database in the industry. And I'm going to talk in a second about the specific architectural decisions we've made to allow me to say that with confidence. But what I also want you to take away is, okay, what areas of my business can I apply this technology? And what we've done is we started to think about things in terms of solutions. And there are 4 of them that I want to talk about. The first is Customer 360. So how do you, on behalf of your businesses, create an integrated, single, omni-channel view of each one of your customers? Catalog and inventory management. How do you deliver relevant product, content, and real-time inventory availability independent of how complicated your inventory may be? How do you maintain that on a real-time basis and ensure that customers are getting accurate information and you can effectively interact with them? Field service, how do you improve productivity of your employees and do so all the way out in the field when they don't have a connection or they're not sitting at company headquarters? And IoT data management, how do we enable companies to manage, support, and deliver real-time insights all the way out to the edge? And these are the solutions that our technology enables. And what we're very proud of is the customers that we have that have already deployed us in making these solutions happen in their respective businesses. And many of you are here today. We spent time last night and we'll continue to over the course of today. Now, you may be asking yourself, well, this seems fairly basic and we've already started deploying this, so how does this all come together? Well, what we want to be more explicit about is how do we make this happen and how do we do so with the performance requirements that you all have in mind? And to build these solutions require a set of use cases that a lot of you are familiar with. Things like user profile, recommendations, operational dashboarding. And some of you, in fact, may be tasked with the solution of go solve this specific problem. But in a lot of cases, it's in the context of this broader solution that you're trying to build on behalf of your companies to allow you to be more competitive. Now, my guess is those of you in the audience are probably not going to a single conference in a year. And some of you may be sitting there saying, well, yeah, this looks really interesting, but there are several vendors that I talk to, and they're all making similar claims. And I'm not going to dispute that at all. What I'm going to tell you, though, is why we're going to do it better and why we do it in a way that other companies don't. And what that comes down to is the fundamentals of our architecture and how we enable these things. So from the very start of our company, we've been focused on building a database for mission-critical applications in the enterprise. And we've always focused on scale and performance as our core tenets. But as we think about our evolution of our technology and how we innovate, there are some core principles that have driven how we've built our product. The first is ease of programmability with the flexible data schema that also combines the power of SQL. And this is how we've taken a query language that replicates SQL and layered that on top of NoSQL that allows you to develop with agility. Our product has a shared nothing, asynchronous, elastic architecture. It's been built to be memory and network-centric, and it allows you to add and remove capacity with a simple click based on your application needs and allowing you to be as cost-effective and responsive as you have as you're building applications. We understand that things like availability are of paramount importance to you, so we've built in replication to our technology. Things like high availability and cross-data replication are core to our architecture, and anytime we add a new service, we're mindful of the implications around availability. We have a philosophy called workload isolation with multidimensional scaling. So as you all know, applications are dependent on storage, memory, and compute, but not all applications require the same mix of that. So how can you effectively add one of those independent of one another to meet the application needs, but do so cost effectively? We've thought about that. We've designed it into the system. We have a location-agnostic geographic distribution of data philosophy. So what that means is you can run our product in the cloud, you can run it all the way out to the edge, and we understand how to manage data at each one of those locations. And with each one of these services, our philosophy is to bring logic to the data, not to try to bring data to the logic. We're deployment agnostic, whether you want to run this on bare metal in a virtualized environment, on-premise, in the cloud. And now we've allowed you to orchestrate all of that through Kubernetes. So these are fundamental core tenets of how we've built our architecture. These things are differentiated. You will not be sitting at another conference and saying, wow, that sounds familiar. This is where we differentiate how we've built our product, and what that enables is what Couchbase is all about. So to reinforce that, I want to go back to the solution matrix and show you how some of this ties together. And I want to talk more specifically about 4 customers that we're proud to call partners as they've executed with us on next-generation applications. Comcast, a company located here in the United States, depends on great service. They've used Couchbase to create a single view of customers across their many lines of businesses. Amadeus, a European-based company, helps all of us keep flying around the world. And they've built a engine that powers the global travel ecosystem. And you can imagine how complex that is with flight times and passengers and all the details that go along with that, constantly changing inventory around the world that they have to manage on behalf of their customers. United, an airline that we often all fly with, actually issued a mandate that they were going to replace all the paper handouts on flights. And they've done that with an application that they built on Couchbase. And Verizon, a company that's in the business of serving their customers with an IoT platform, allows companies to build applications all the way out to the edge and increase their presence in IoT. So these are companies that have taken advantage of Couchbase. Now, when I hear about that, it's still not enough for me to understand, well, what is it about Couchbase that made this happen? And what really brings it home is the performance requirements that each one of these companies had before they could say, I was successful. So at Comcast, it's not just about an integrated view. It's how do I do that for 100,000 internal users that are accessing 210 million documents? That kind of data volume, those types of performance requirements need a new way of thinking and need a differentiated architecture to serve those applications. At Amadeus, their inventory platform processes 7 million requests per second. And for them to be successful in business, they have to process all of those in less than 2.5 millisecond response times. That's a different type of challenge that requires a different platform. At United, the replacing paper, which sounds convenient and pretty straightforward, imagine changing the experience for 41,000 employees, flight attendants, baggage carriers, pilots, that are all responsible for the thousands of flights that United gets up and down every day and ensuring we not only arrive safely, but we arrive satisfied. 148 million travelers in 2017. Imagine the data volume and the complexity of an application that brings all that together. And at Verizon, their IoT management system drives 3.5 million operations per second, processing 500,000 events per second. So when we think about the fourth industrial revolution and we talk about things like digital transformation and we talk about creating better customer experiences or improving the experience that an employee has, success is not just building an application, which is why companies are investing $24 million apiece to try to get after these things. Now, what's fascinating as we talk to all of you is not all of them are successful because this is really, really hard. And what success means is not just having an application, but having an application that can support these types of data requirements. And so when you think about Couchbase, what you need to realize is that we have architected for these types of applications, high-performing, scalable, mission-critical applications. They're going to help you take advantage of what's happening in the world and make sure that we're driving that, not just being a passenger on the bus. So what we pride ourselves at Couchbase is solving real solutions to really hard problems. And as you walk around today, you're going to talk to the many people that make this happen. But this isn't about simple problems that we work through quickly. These are deep computer science challenges that require a different approach. And that's what we've been architecting as a company and why we're so excited to have you all here today to continue to talk about innovation. And at the end of the day, what that platform enables through our integrated use cases that enable those solutions is to create a better customer experience, to allow you to innovate faster than the competition, and do so at a lower total cost of ownership. These are the business values that are unlocked with the power of the Couchbase data platform. So you can see then why our mission is to be the data platform that revolutionizes digital innovation. We want to be a partner to our existing customers as you continue to expand and push the envelope on the applications you're building, and helping you fundamentally change your business to be more successful. And we're going to continue to relentlessly push the envelope on innovation while still keeping those core tenets in mind, never sacrificing scale and performance, because that's what we stand for. Thank you very much for being here. We look forward to this event as we lead up to it. We appreciate all of you being here, and want to continue the dialogue. We're going to do a lot of talking about what we have. We also want to do a lot of listening. And a big part of what makes Couchbase what it is being customer focused and taking our innovation in the direction that all of you help us define. But it gives me great pleasure to now bring our Chief Technology Officer and Head of Engineering, Ravi Mayuram, to the stage, as he's going to take us through, in more depth, this new service that we're announcing called Analytics. Thank you very much.
Good morning, everybody. It's great to see you all here. I hope you all got sufficiently warmed up with Matt's introduction to the concept of a massively interactive enterprise. And we live in a pretty complex society. So all the low-hanging fruits and simple problems, we've taken care of that a while ago. So all the enterprises are getting to that stage of being massively interactive. A lot of systems have to engage with each other before you can actually produce the goods and the service. But more than that, with this newer sort of economy that's emerging in front of us, it's not about goods and services alone. It's about the experience of how you find those goods and services that's actually distinguishing how we are all going to evolve. There was a time when there was someone helping you. Now that someone helping you is yourself, because it's sort of presented to you in a different manner. That's the whole idea behind why the interactions are more and why engagement is that much more sought after. Now, when you look at this massively interactive enterprise, from a technologist point of view, this is how it appears. And some of you live this, and some of you may not have an inclination of what it is. But I can assure you, both of you, one who knows this intimately and one who knows nothing about this, are equally staring at this with a confused look. What the heck is this whole thing? Where do I look? Is generally the first thing that you will actually come to. If you think it's like some sort of a photographic mosaic, which if you stare a little deeper, you will find a Mona Lisa smiling. There's nothing more to it than what you're really staring at, which is just chaos. And chaos really rules here, which is that little flap of a butterfly's wing in one end or one corner here will actually cause massive disruption on some other part which you don't know, which you can't predict, which you can't anticipate. And if you really get to the next level of detail as to why that is happening, it has all got to do with this. If you look at each of those solutions over there, they were developed over a point of various points in time as we have evolved. And they all require you to sort of move data and keep them slightly differently from the other source. And this actually leads to data sprawl, which essentially translates to the fact that it is now a database sprawl, because everywhere, wherever you store data in some form, it is a database. Whether it's truly a database, which actually is defined to be one or not, it could be subjective in terms of whether you look at a search system as a database, but it is one because it's storing and retrieving and persisting and delivering data. So it just makes the whole thing to be a huge sprawl. At the end of the day, what you're looking for is, number one, you're running the operations of your company. Number two, you're looking to see, how is it actually working? And you're looking for insights. And these insights is why half those sprawl that you saw over there is actually in place. And the insights, it's a very subjective thing. It depends on how good your pipeline is in one sense. How good the data moves and how effectively is it moved and how close to a decision point that you actually find the data. So that's basically what this database sprawl actually leads to. One more deeper look into this whole problem is the whole pipeline, how it is set up. Because the data has to move. If it doesn't move, then you don't find the insights. You don't find the value out of it. It's almost like people have used this concept of saying data is the new oil. If you really think about it, they said it just from the standpoint of economic perspective or the industrial revolution. The last one was oil-driven. This one is data-driven, is how it was characterized. But really, if you look at it, it is truly like oil, as in Crude is useless. You can only at best heat your home with it. But only when you fractionally distill it every stage, you find the value out of it: petroleum, kerosene, diesel, Vaseline, petrochemicals, plastic, everything comes out of various stages of this refinement of it. And that's why that huge sprawl I put up there is that it's actually doing something. But there is no pipeline. You're actually moving, lifting and shifting every time. And so every change that you actually make in this, since it's not a smooth pipeline, it actually puts the accuracy of what you're looking for at risk. Let's go one level deeper as to why this actually happens. We all know how the landscape is. There's an operational database and there's an analytical database. In the operational side of the database, you run the business, for which that means there is a application that you have built which runs your business. And on the analytical side is where you go to find the insight. What do you do to do this insight finding? Because the operational side of the house is the money. So you don't want anything to impact that. Customers should have the best experience. There should be no glitch. So you take this workloads of insights away from that operational system, run on a different system, which is the insight system. Now, the insight systems have very different requirements from the operational system. So what do? You denormalize tables, you do cubes, or whatever you have to do to get the data onto that, into a format that system likes, and that's how you get to your insights. So to do this thing, there is a whole other industry in between, which is the data integration piece of it, and that does what is famously known as ETL, extract, transform, and load. The extract and load are, in their own way, little challenges, but the transform is where actually most of the action is, because this is where you get into another development phase of figuring out the data model design, the development of it, and the whole life cycle of dev, bug fix, prod kind of situation. So that's where a bulk of the effort is actually spent. Now, in order for you to find the insight, there used to be days early on when you say, oh, come back to me after 3 months. Here, take a number, because it takes that long to move the data, generate the report, find the insight. That has all shrunk a bit over the last 20-odd years, but still, it is a pretty big process. And it's a couple of week process, because dev, test, prod of anything you're developing, few weeks are always spent. But that is just the part of when you have decided what to do. Before you make a decision and go through your organizational, now people are involved here, so it always gets slightly more complex. Little organizational politics gets in the way. Roadblocks are there. So you get through that process, God knows how long, but at least the implementation of it in a couple of weeks is what you could say it typically takes. Now then the application evolves. God forbid you make a schema change. You have to go through the same process of the committee coming together to figure out what changes to make, what schemas design needs to happen on the analytical side to adjust to this schema change, the operational side. Again, the same issue. Obviously, it's a massively interactive enterprise. New data sources have to be fed into that application to make it more effective. One more cycle of changes happen. So every time you touch something on one end, this is the butterfly. The other end is the storm that's actually brewing. And this is the reality we live in. And this is why insights come much later. It's almost like economists telling you that our economy is really, up there. It's really doing really well. But I can tell you by the 280 backlog on Page Mill Road that the economy is doing really well 3 months before these guys can tell you. Because I can see it versus they have to crunch through all this stuff before they can actually put a report in front of you to justify that. But we can get there much faster. The question we ask ourselves is, what if there were no ETL? Can we get to a world where instead of doing this transformation, which is almost like chewing gum, baling wire kind of stuff that we keep doing, and most of the effort is spent not on the creative side, but in the sort of the operational, the mechanical element of moving data and making some changes and going through the dev life cycle of it, without actually the creative part of it. What if we got to a place where there was no ETL? So let me break the same picture in a different way. What you're actually seeing is 3 major systems, not simple applications. These are systems deeply thought through, systemic database conceptual systems, not one-off, because these are platforms on which you can build applications, sophisticated beasts. One is an operational database, OLTP as it was called. Then there is, which is all about running the business. The other side is the in-between, is basically your integration platform, which can do a whole bunch of stuff. How many databases can I talk to? How can I transform from one type to the other? It's an evolved beast in its own way. The second system is that integration system. Third is the analytical system. In one sense, what you have to answer in this case is that how can you collapse three systems? How can you consolidate three layers? How can you consolidate three different disparate systems into one? And how you do it also matters, because if you get it wrong, you will get into a different set of problems. But you have to get it into a place where three systems come together and they give you the benefit. What if the scenarios were like this? That without going through that complex cycle of every time you touch one thing on the operational side, leads to a storm of you doing your ETL work, and the analytics side has to also change based on the stuff that you do. What if the operational side makes a change and just the data is transported, if you will, or streamed? It's got its own connotations, so I don't want to use that term. The data just automatically finds its way into an analytical system, and the analytical system basically moves it to a place where you can find your insights. What if you had a system where you could see this all in action together? So without me giving you more of the architectural details, which I'll come to later, some say picture is 1,000 words. Sometimes live demos are 1,000 pictures. So let's take a look at how this whole thing works in action, and then we can go and look at what are the complex problems we need to solve to simplify it. So we'll show a lot of stuff. Please see if you can digest. If not, we will always be available through a video recording at some point. Take a look. So to give you further look into how we have built this system and how it actually operates, I'm going to welcome onto the stage our Director of Product Marketing, Product Management for Analytics, Sachin Samotra. There you are, Sachin.
Hey, Ravi.
Welcome.
Thank you.
Good to have you.
Great to be back on the Connect stage with you.
Lovely. What you got in store for us, Sachin?
So I'm going to be building on the theme of the massively interactive enterprise that was talked about earlier, and we're going to make it real for us. We're going to tackle the connected car use case. It's not going to be news to people here in the Silicon Valley. We spend a lot of time in our cars, and many times now our cars know a lot more about the health of the cars themselves and also about us. And all of that information is being sent back to manufacturers to keep track of.
Fantastic. So the connected car manufacturer is actually running a whole bunch of stuff on Couchbase. What do you think they're doing with the data that the cars are sending back to the enterprise?
So there are three key personas that we're going to talk through and walk through today. The first one is a business operations manager who would like to keep track of any changes, anomalies, exceptions in their data and be able to react to it in quick time. The second one is an IT analyst who would like to delve deeper into data to react to such changes. And last but not the least, a data scientist who is in the world of machine learning models and love the tools that they work with. So you're going to show us a Couchbase cluster which is actually sort of running all these operational workloads out there? Absolutely, Ravi. So what you see on screen right now is the Couchbase cluster that is actually running the business of the cars. So what you have here is almost 500,000 operations running on a Couchbase cluster where cars are sending their data back to the mothership.
Lovely. And when this data comes in, then the operational people can take action and they can basically get this to the next level of finding insights out of that.
Absolutely, Ravi. So
I see that you're distracted with changing a text over there. Work-life balance is all good, but we are doing a demo on stage here.
I want to assure you that this is a very important message, and it's not my wife sending me a text about what I'm going to be doing over the weekend. So if I go to the message right now, you'll see that I've gotten a notification from a connected car. It tells me that number one, work-life balance is still impacted. Number two, the tire pressure monitoring system on one of the cars is actually giving me an anomalous reading, and it is basically giving me the VIN number of the car in real time as we speak.
Lovely. So all those 500,000 or so operations per seconds are coming into the system. It detected something and then it sent you a notification about TPMS alert kind of stuff.
Absolutely.
So what you're seeing here is the first part of what I wanted to highlight here is our eventing infrastructure here in play. So what it actually did was you are looking for an event to happen based on which you want to take an action. It's built on this paradigm which we call event, condition, and action. So what it basically did was every sort of data that is coming into Couchbase, it was looking for what to do with it. So you register something called a callback and you can take an action based on the event that is happening. In this case, looks like it noticed that there is some tire pressure issue in some other cars that's coming in and gave you an alert.
So let me show you how this alert was configured. Let me just look at the walk to the eventing part of the framework. You'll see there's a function defined over here. I'm just going to go ahead and zoom this up so that you can see this better in the back. What you see here on the top line is how the event was actually triggered. There's a bunch of, like Ravi was saying, events that are happening, which means cars are sending data back to Couchbase. There are certain conditions which are defined on top over here, with the tire pressure indicator being on, the outside temperature being beyond a certain threshold, and then the engine temperature going beyond a certain threshold as well. And that's what is triggering the action of the SMS coming to me at a very important time here while we're on stage.
Live on stage. Nothing like it. So this data is coming in from the car.
Absolutely.
And you're observing it and you're taking action based on what's happening over there.
That is correct.
Now, what kind of data is the car sending? Does it give you all the data that you need for sort of to find out what's really going on or what kind of insights you want to trigger out of it?
Sure. So what you're seeing on the left-hand side is of your screen is the JSON model of the data that is coming from the car. You've got a bunch of information about the engine temperature, the reading of the sensors, the tire pressure readings themselves, which you will notice is actually a JSON array. There's also the location of the cars that is being sent as a latitude and longitude that is coming in. The VIN and all of the other information, that's the key for having this in there. And on the right-hand side, what we're doing is we're essentially enriching the information that is coming in. And what we're doing is we're adding the model type, the model year, the year in which the car was manufactured, as the data is coming into Couchbase.
Perfect. So you're basically getting the data that's coming from the car. And this is what we would call like a data enrichment is what you're doing by adding, to put it in analytical terms, what is basically adding is dimensions to the facts are what is coming from the car, and he's adding more dimensions to it, so you can now do deeper look into it.
Absolutely.
Now, right? And so, these dimensions, you added 3 of them?
Yes, I just added the origin country, the model year, and the model type of the car as additional dimensions for analyzing the data when we start to analyze it.
Fantastic. So in one sense, this is where your sort of the ETL magic is actually happening. Programmatically, you have set it up so that when an event actually happens, you embellish the data and you're actually extending. If you were to do this in a relational world and the existing infrastructure, you will first change the schema on the operational side, which is the second part that we talked about, and then you will basically have to go change your schema on the analytics side as well, the facts and dimensions, additions and all you need to do. And between is all the stitching of the pipeline, which has to undergo the whole dev cycle. This is all after the committee has really approved that you can make this change. So all that in one sense you can do in this eventing framework, which is doing 2 things for you. Programmatically, you're able to register what was it that you want to do and it fires. First is this event condition action. The second is this code that you're seeing here is distributed compute. As in this code is actually managed in the Couchbase server, eventing service. So it will distribute scale in, scale out based on capacity. This code doesn't have to run on the app server where you'll have to run it on 50,000 app servers maybe. Instead, you can run it on the Couchbase server. And then there, based on elastic capacity, where should this code run is also determined by the server, so it automatically moves the data and fires it moves the code logic and fires it in the appropriate nodes where it should be when you scale it out. Right. So fantastic. So this is where the eventing action is in terms of getting you the data. This is what makes the data really flow from one system to the other in a programmatic manner. And this is possible because of the original principle of schema flexibility. Both ends are schema flexible. Notice that. Fantastic. So now that you are actually done this thing, this data is on the analytics side. Now,
this is on the analytics side. What I'm going to do is I'm going to switch gears completely, and I'm going to put on my IT analyst hat. And I got an alert. I want to do some data exploration with that alert. The first thing that I'm going to do is find out if this is a one-off situation or this is affecting more than a whole lot of people.
How many cars are actually sending in this
How
data?
many cars are actually sending such messages? So what you see on screen, and let me actually blow this up a little bit, is a query that's going to query all of the information that was coming in live, and I'm going to see whether there's more than 1,000 cars, because I'm just on my screen here. As you can see, I'm limiting the number of documents coming back to 1,000. What that's telling me is there is more than one person on the road that is facing this problem.
Lovely. So I think what you will do as an analyst is now look at further. You want to see how critical this sort of information that is coming in?
Absolutely, Ravi. So the first thing I do is we just added a new dimension, which was the model type. So let me go and see whether there's only one model of the car that's having this issue, or there is multiple models of the cars that are having this issue. There's a query right there where I'm getting the model type and the count of those. For those of us who are SQL pros, this will be easy to read. So you'll see that the first conclusion I have from this is that this is not limited to one type of car. There's a bunch of cars that are types of cars that are seeing this issue.
Fantastic. Since you're seeing multiple types of cars, then of course the question comes, how critical is it? What sort of an emergency are we facing here?
Absolutely, Ravi. So the first thing that I like to do once I've explored the data a little bit is, should I rule out false positives? Let's see if there's actually a problem with the tire pressure readings that was coming from the car, or this is just some faulty indicator. So what I have here is, and this is a very interesting query, where I am querying the actual reading that is coming from the tire pressures in real time. And I am making sure that that is above 30 psi, which is a safe limit. And if there's a bunch of cars that are satisfying this requirement, that means that even though the tire pressure is normal, the tire pressure monitoring system indicator is on. So let me execute that query, and you'll see that there's a bunch of cars that are satisfying this. So this seems like a false positive.
Okay.
It's like, although the cars are sending that indicator on, but there's nothing wrong with the tires right now.
Okay. Fantastic. So now that you have actually shown us, I think there's one critical element here which to me feels like you're glossing over a little bit, which is the setting up of the whole analytical system and moving the data. This is what we are saying is really simple, but that part of setting it up and getting the data across, that is a huge piece of the work. So are we taking a little easy route here by showing all this stuff on
Not at all, Ravi. Setting up analytics is really, really easy. What if I told you that I can set up analytics, add a new node in 5 clicks right here on stage?
So he's signing himself for a challenge, so obviously we got to take that, right? It's basically saying you're going to set up analytics and get the data over to the other side in 5 clicks. Now, I would like all of your counting arithmetic skills here a little bit to make sure that we keep him honest, right? We'll start counting the clicks to make sure he actually lands on 5. All right, we have everybody here, so you got to make me look good.
All right. So what you see here is the Couchbase cluster that I have set up for the demo. You would see that there is only one analytics node right now. And as a part of this demonstration on stage, I'm going to add a brand new node and make sure it's in 5 clicks. So the first click, I'm just going to start by saying that I want to add a server.
Click 1, right? Please keep count with me. I'm not a rock star, so I can't make you clap 1, 2, but.
So please. I have a Couchbase server where I have set up the latest release of Couchbase, which is a 6.0 beta that's available on our website. And no, Ravi, the tabs don't count. So I'm just going to type in the username and the password.
Fantastic, but I see a pitfall coming in front of you. You all notice that, right? It's got so many clicks out there. Unclick is also a click. Do we agree?
I will agree with that, but I do have an ace up my sleeve. I do have a secret shortcut that I can use, and I can only select analytics.
Look at that, one click. So we are on click 2, right? You only click twice so far. Tabs don't count. So click 2. All right. What next?
I'm going to physically now add this server to the cluster. And that was
click 3.
Okay.
People, keep me honest here. It's 3 clicks so far that he has done. And after this, what's going to happen?
So there is this last step of rebalancing, and that's going to be my last click right now. So
fantastic. What's happening here is the data is sort of getting ingested into the analytics side?
Absolutely. So what we had initially was just one analytics node on this cluster. And what I've done is I've added a brand new analytics node. And by pressing the rebalance button, what I'm telling the analytics service is that now you can distribute your data across 2 nodes, which is the whole linear scaling of the analytics service.
Fantastic. So what we're actually seeing here is the data sort of being moved, all those 500,000 ops per second that was coming in. That data is actually being ingested onto the analytics side, and this he started by elastically scaling our nodes. That's all you had. You added a new type of service called analytics, and then he hit the rebalance button. Many of you who have used the product know rebalance is our magic of moving or elastic expansion of the capabilities. So here we have extended the platform elastically to add an analytics node, and the data has been, it's already moved?
It's already moved, Ravi.
I thought I had to talk for longer to cover for that, but it's moved. On to the next. So that's click 4.
That was 4 clicks.
That means we have the data on the analytics side on 4 clicks.
Yes. So I've just added a brand new analytics node in 4, not 5 clicks.
Off by 1 error. Classic developer mistake, right? So how did you come to 5 then? Is it over-promise, under-deliver problem?
It's the same over-promise and rather over-deliver and under-promise problem.
Okay. I mean, my management Freudian slip came. So in 5 clicks, ladies and gentlemen, you have the analytics cluster set up on the other side where none existed before. So the operational data has gone into the analytics cluster in 5 clicks in less than what, 5 minutes that we were on stage?
Yes.
Isn't that an achievement? Thank you. Thank him. Now, but this is not where you know me. I mean, okay, the data is there, but it's all about.
There he goes again. I just added a new node in 4, not 5 clicks, and he's still not satisfied.
Correct.
There's a but, and Ravi, you're a really hard man to please.
The but is all about me. I'm a visual kind of a guy, so you got to show me something. I understood all the queries you did over there, and that's the basic stuff underneath, but I want to see this in, or if I have to show this to Matt, he's going to SQL mumbo jumbo ain't going to work there. So you got to show it to him. When I have to tell him what is really happening in this massively interactive enterprise, it's about little presentation is required, right? How do we get to a point where we can show these reports?
Sure.
That's the question. That's my but.
I think that's a great segue into what we want to show you next. What I'm going to bring up is a section where I'm going to essentially bring in data from Couchbase in its natural form and show you what it looks like on one of our partner tools. So what I've done is I've essentially, with a slow network connection, navigated to one of our partners, which is Novi, that have built a native Couchbase integration. And on Ravi's request, what I've done is I've set up a data source that is connecting to our Connect demo cluster and is bringing all of the data back in a tabular fashion, no pun intended. And what I'm going to do is transform this on the fly and turn it into a map.
Okay.
So I'm going to go into the settings section, and my visualization would change. The only thing I'd like to note is that we are getting the latitude and longitude of the cars being sent as a part of the live data, like I'd shown in the JSON model. And I'm going to choose a zoom level that's going to make this a little bit easier on the eyes. So let me choose a zoom level of 7. I'm just going to save this, and in, I don't know, 3, maybe 4 clicks, I am going to refresh this page, and then you should see the map show up over here.
Fantastic. So what you basically showed is that using the NOE reporting tool, you have basically now created a report of the data that is coming in, which is giving us a sense of where this tire pressure anomaly is coming from in a map, so that you have a sense of is there a clustered problem, or is there issue all over the place, what is it. So if I were to look at this, what this sort of tells me that there's a majority of it is happening right here in our backyard. Is that the first insight I can drive out of this?
Absolutely. It looks like most of the cars that are reporting these issues are in the Bay Area.
Perfect. Can I ask you further questions now in terms of these, what types of cars, or what can be further insight be? I mean, I would love to know, which types of cars are having this issue. Is that a reasonable question to ask?
That is a great question to ask, Ravi. In fact, I think I was thinking the same thing. I like to think that great men think alike.
Great minds.
So,
fools seldom differ.
What I did was I created a plot of the same data where I'm grouping by the new dimension that we'd added, which is the model type. And here's what that plot looks like, Ravi. Does that picture tell you a story?
Tells me convertibles are having more problem than the other. But typically, there'll be a lot more other types of cars than convertibles. So this perhaps tells me that among the different types of cars, it's the convertible type that is having more issues with the tire pressure indicator showing up.
Absolutely. It looks like convertibles on the road are the ones that are reporting the most issues with the tire pressures in real time right now.
Since I took a peek look at some of your queries over there, perhaps we can refine this further to see, is there a certain model here or something which is giving more trouble than the others?
Sure. So what I'd like to do is, at this point, basically do some further analysis and make sure that this is not an emergency or a situation that requires any urgent attention.
You're thinking of that. Sure.
So we had, going back to the same visualization, we also had the engine temperature reading coming in. Mm-hmm. What if I could also plot the engine temperature, the average reading coming in from the cars?
So you're just making sure it's not a life-threatening thing.
I am making sure that it's not an urgent situation that we need to take care of and tell the rest of the folks about it. So what you're seeing is a new visualization of the same data, which took me a couple of minutes to get there, where the average engine temperature being reported by the cars is shown. If you look at the scale on the right, and I'm just going to zoom this a little bit to maybe make it look a little bit better, all of the cars are reporting an average temperature between 199 and 202 degrees, which is within the safe zone. So we can safely conclude that there is no urgency or there's no urgent issue on the road.
I can breathe easier.
Yes.
Now on to my original question of, can we look at further, see which types of cars are actually which year, or can we further narrow it down? So when we stand in front of Matt, we can give him slightly more reassuring answer.
Absolutely. Not. So the big thing here is that convertibles are having an issue.
Yes.
And if we actually also added another dimension, which was the year in which the convertible was manufactured. If I was to slice and dice just the convertible data and plot that in a very similar graph, rather a pie chart like the last time, here's the picture telling us the story, Ravi. What do you conclude from this?
What this tells me, with my limited knowledge of things, is that 2017 convertibles are having a tire pressure related issue, which is not an emergency because the engine temperature seems to be fine, and a good chunk of them are happening in the Bay Area.
That is correct.
Lovely. So you derived at an insight as to what type of car is having a problem, what model year, what type of car. From the standpoint of getting a notification that some anomaly is actually happening in the system, I would say in less than 5-7 minutes, based on what we just showed you, from the moment the event was triggered, where you saw, to the point that where you could generate this report and show us as to where issues would be happening. The real thing here is that you're able to catch stuff that is happening while it is happening. So it's about the data enrichment and event-oriented look of the data. So actionable insight is now within minutes. If it was in the original system, you'd have let the needle go hide in a haystack first. That's what's on the analytics side. You'll batch the whole thing over to the other side and keep finding that needle. And that's because you didn't act on it at the time when stuff was happening. So you first complicate the problem and then try to solve it and say, oh, I have a huge, massive, big data problem. Don't create certain problems, but we can solve it much more easily. So that's what Sachin took the risk on stage to demonstrate that event happens and the insight is delivered to you while we are talking here. So I think it's a quantum leap in terms of how we do things so far and where things can be. I'll let your imaginations fly after this. Now, Sachin, what happens in enterprises is that there are other battles you have to fight, which is, I'm already invested in this visualization tool or the other one, and how can this sort of report, be delivered in places where people are already used to, like a Tableau or Cognos or any of those which are the popular ones in the enterprise?
So that's a great question, Ravi. In fact, our strategy with Couchbase Analytics is that we don't want to disrupt your existing tool set, and we will work with whatever tools that you're working with. So we have an ODBC, JDBC connector that CData, one of our ecosystem partners, has built. And what I'm going to flash on screen right now is the exact same visualization that I showed you plotting live on the graph on Novi, is again connected to the same cluster and being displayed on a Tableau dashboard. So you'll recognize the pie chart with the convertibles on the left, and then I have been a little bit more imaginative and trying to like get the yearly breakdown of all the cars convertibles that are having this issue.
You also mentioned the third, the operational people, the analytics, business analysts, and finally the data scientists. What can they derive further insights out of this data, or be set up for tooling for which they are used to?
Absolutely, Ravi. So the proof is in the pudding, and I'm going to go back and show you a Jupyter notebook that you will recognize is showing the exact same plot that I had from my earlier visualization, where I am connecting using the Couchbase Python SDK. And then you'll see the second plot over there as well. And last but not the least, my favorite part of this is all of the information from Couchbase, the data is available in a pandas data frame. And I've gotten that code snapshot over here, if you can see it in the back. And right after this demo, I'm going to take a course in machine learning and start building my models.
Yep, I'm going to follow you right after. So the data seamlessly flows. I think that's what is basically demonstrated. You can find insights which are at the analyst level, or you can go deeper where you want to do more complex processing of the event, and that's all accomplished with the data frames that's available to you now. All this is good. So far I have distracted you all with the major thing, which is that this is all analytical stuff happening, and you know how many complex queries have to fire to get you these insights. While all this is happening, what's happening to the running of my business? Is it still operating and giving the user experience that they are actually used to, or is it degrading because I'm doing all these analytical queries while the operation is still running?
So let me just go back to where we started, which is the Couchbase console. And I'm just going to go to the statistics right here. And this is the same cluster. You'll see the number of nodes right now is 4, because we added 1 node as a part of this demo. And we're still doing 500,000 operations per second, which means in the last 15 minutes or so that we've been on stage, this cluster on the has handled 600 million mutations, if my mathematics is right, while we've been on stage in the last 15 minutes, and Couchbase hasn't blinked.
Fantastic. And the analytics reports were running while this operational workload was constant, so to say.
I was doing my data exploration where I had no predefined indexes. I didn't know what data I was going to be looking for, and all of that was happening in parallel as we were serving 500,000 operations per second.
Ad hoc querying up the wazoo without that impacting the operational side.
Absolutely.
Fantastic. Ladies and gentlemen, that's the demo this guy put together with a whole bunch of people who helped putting this demo together, which just showcases you how an operational and an analytical system can work in the same data platform, one not impeding the other, and that's our multidimensional scaling and our scale-out architecture all coming into play. Thank you very much, Sachin. This has been an impressive presentation.
Thank you, Ray.
Looking forward to more of this. Thank you. Now, all this is fantastic when you look at this level because we have sort of hiding a lot of complexity. May actually even to you look like, oh, so what's the big deal? It's the same report I'm running here. But underneath it is where all the magic is. And you all know how we are able to show both these in one place. But in order for us to do this, we have had to solve some very difficult problems, deep computer science problems that we have had to solve. And to give you a sense of what kinds of issues we really solved and how we actually solved this, the brains behind this all, I would like to introduce you to Professor Mike Carey, who will give you what all went to building into this system into place. So please welcome Mike onto the stage. Mike, pleasure, privilege, and an honor to share the stage with you. So Mike, first thing I noticed is that in that image that we put of you over there was a asterisk DB on your lovely shirt over there. Yeah. Like maybe that's a good point to begin.
All right, yeah, so basically about 10 years ago, I quit my Silicon Valley day job. I moved south to the sort of the University of California campuses down there and was faced with a question, which is like, now what, right? So you have to have a research agenda, you have to work with graduate students, and so the decision was, let's look around and see what's happening. I love to build systems, I like large software projects, and started a project called Asterix. At that time, it was like the beginning of big data. You could kind of see it coming. Social media was starting to happen. There's going to be a lot of data generated. And the question was, what are we going to do with this data? How can we do what we were calling kind of web warehousing? From an architectural standpoint, there was an elephant in the room, Hadoop, right, which was starting to happen. There was, clearly the data was a mess, right? It was much more complicated than rows and columns. And databases were kind of being forgotten, right? So people were kind of reinventing, sort of that technology without being aware of it. And so those of us who were like the sort of SoCal database people said, this is not the right way to go. Let's build a parallel database for that kind of flexible data, and that was the Asterix project.
Fantastic, and there was the document database. There was a document model that you had chosen for that. And so when I heard about this, that Mike was developing this and through common connections, I was very excited and I actually flew down. I hope you remember, I came down to meet you in UCI and because a lot of shared stuff was there. So I think out of that, led to this day.
So I think what we realized was we had sort of a similar vision for where things were going, right? You had not forgotten about database technology, right? You were on the verge of building like the first, sort of operational query-based, scalable thing for the operational side. And what we were doing was essentially building for the sort of the OLAP equivalent for NoSQL data.
BDMS used to call it.
BDMS, a big data management system, right? I'm not dyslexic, it really was BDMS. And the goal was essentially for us to be able to do that kind of analysis, analytics over that kind of data. And we realized it looked like we had kind of a Reese's peanut butter thing happening, which is, we have chocolate, we have peanut butter, we can put them together. We had what you might call OLAP for NoSQL. You had OLTP for NoSQL. And if you put them together, before HTAP was a thing, we realized we could build like one platform that could then sort of solve both pieces of the puzzle.
The hybridization of both in one thing. And but that required a lot of complex problems to be solved. And so that was where the NoETL basically came into sort of the collective thinking. What if, I think your point about schema not being rigid gives us that ability to fuse these two, and if we did the right architectural decisions, they could come together as one. What were some of the tough issues that we basically had to solve, or the design principles that you had to basically go back to? The NoETL being one of the first ones that you started with.
So basically there's sort of two big technical problems. One is that you were doing a lot of transactions per second on the front end, generating a lot of data, and that had to get swallowed into the system where you could ask the big questions without perturbing the front end. And so there's a data ingestion issue there. And so there we had to look at how do we get the data in, sort of moved quickly, and how do we get it at rest quickly so that you can query it. And so we had some technologies that were relevant in AsterixDB. We had something called data feeds. And we also had a storage system that we had built based on log-structured merge trees, which are kind of the way that you organize your data if you want to ingest it as well as query it. And so basically one of the problems was ingestion. And we had to build sort of a highly parallel version of a DCP listener.
NPP stuff.
Sort of a many-to-many DCP listener that would get things in. So it was a scalable listener. And then we also had to sort of harden and build out our LSM storage structure so that we could do those kinds of queries. And then on the query processing side, we needed to be able to answer, like you went through a demo here where it was question after question that you didn't know you were going to ask until you saw the data. Ad hoc queries. And so for that, you need parallel query processing. And again, we had looked at what's going on in parallel databases, what was going on in sort of the Hadoop world, what was going on with semi-structured data, and it already made a big head start towards having a parallel query processor for NoSQL data. And so we continued to sort of solve those problems and develop that out so that we could do all the kinds of things, you know, the parallel sorts, parallel joins, and so on, to solve those queries at the speed that you saw.
Lovely. We'll talk more in the afternoon, but one of the common thing was how do we take SQL to the next level, so to say, as opposed to yet another query language. And I think a lot of the mind meld was over that stuff as well in terms of how you could do SQL on a, as you would call it, not flat a data model. I think that powered the next level of innovation.
That was another big piece. We had, in Asterix, I went back to, you know, sort of to university and went, okay, all the rules are off, I can do what I want. We invented a new query language called AQL, the Asterix query language, which had sort of the power of SQL, but a different syntax. And you were sort of going down the road of, okay, let's be something more SQL-like, and you had Nickel. And so one of the other problems was converging those two things.
Fantastic. So we've really brought them all together. And finally, that gives us the hybrid operational analytical system in place. And one of your biggest things has always been, why do all this? Sure, I can be academic about this, but then what's the real benefit, which, like you would say, is the time to insight.
Yeah, exactly. So the kind of the design principles were, you know, sort of aimed at getting that time to insight down to what you saw here, right? Which is essentially, rather than needing to do that multi-week project of ETL and then having to get those reports generated, you could just basically, you know, in 5 clicks apparently, right? You can sort of get there, you can be asking your questions. And so getting that ETL out of the way got that time to insight down to where you could actually be doing things in minutes rather than doing things in long.
Basically, it makes the whole process lighter and easy for people to get to, instead of it looking like a chore or a punishment to get that thing. I think that, from your academic purity perspective, what have you really solved? Like, underneath is all beautiful.
The right way to solve the problem.
Right way to solve the problem, as you would say. Thank you, Mike. Without you, I don't think we would have made this day a possibility at all. With all that you've built and all the knowledge that you've shared with us, because you've done this database stuff for a good 30-odd years, all the way from University of Wisconsin. So your expertise, your wisdom has guided us tremendously out here. Thank you very much to you and your team for making this a possibility today. Thank you
for having me.
So that's about 35 years of wisdom in databases, where people fly in from different countries to ask Mike what we should be doing about our data, governments and enterprises. So that's the expertise that we have here who have helped us build this system. So it's not an easy problem to solve. So don't try this at home. Use the product. Don't think that you can solve this problem by, you know, hodgepodging 3 different open source projects and sticking it together and I can also do it. It's not the case here. Because there is that mentality of, you know, I'll build it or it's not built here kind of thing in some enterprises. This is some serious stuff that we have built here. And to highlight to you, you know, what we have really achieved here is basically bringing the operational and the analytical in one system. And you do this by hanging on to your design principles. You cannot do this in a hodgepodge or, you know, you don't wake up one day and say this thing's happened. The conversation me and Mike had is about almost 4 years old now, right? I mean, so it's about getting your design principles right and setting up your fundamental architecture right on which you can do these things. So what are the things that come here? One is our elastic scaling. A shared nothing distributed architecture is fundamental here. Why? That puts network in the middle, which means you can now scale instead of doing a infused architecture, just like older databases were like airplanes. If you want to add more capacity, you have to build a new airplane. The way we have built this is like a train. If you want more capacity, 20 more seats, add another coach. If you want a different type of coach, you can add that too. That's what we just did, right? As an analytics, just got added on to it. So network is more reliable, faster. It's actually faster to get across to a data on the memory of the next node than getting it from the disk. Remember that. So all those disk-oriented principles are also a little ancient right now. But we built that on the shared nothing distributed architecture. To that, we added uniquely the workload isolation capability, which gives us, that's exactly what you saw in action here. All the analytical queries ran there in those 2 nodes that I showed you, whereas the operational workload was running on 3 other nodes on the other side. One did not impede the other. It's sort of fenced nicely. And on top of this, all this is goodness, but if you don't make it easy for you to operate, then it becomes difficult. So what did we do for that? That's where the nickel, we extended nickel from the operational side to the analytics side. This is akin to saying that I give you the same steering wheel and the gas pedals and the gear. You can drive a Mini with it, or you can do your Ford F-250 with the same thing. Don't confuse just because both have the steering wheel, that's the same thing. It is not. One is for speed, other is for hauling. So both in the same system is how we have basically built this. So one platform where you can run your business, and in the same platform where you can find what is it that your business needs to change. Does it require a change? First, you have to ask the question, if it is suboptimal or is it running optimally? Find out what, if any, change is required, and what should it change to. It gives you both those things. It told us in 5 minutes that yes, there is an issue with car pressure. No, it's not an emergency because engine is fine. And it is an issue in 2017 convertible models. So now you know actionable insight is to see what do we need to do with the tires that we actually, did we change the manufacturer of the tires done? Is there a tire recall? Can get to that specificity. So that's how you optimize your business. That's what you're able to do in one platform because it's built on those design principles. Matt talked to you earlier about how our sort of core mission is to revolutionize the data platform. And revolutions are small steps to begin with. They are called revolutions post-fact. Some of the stuff that we showed you here, I hope it gives you the perspective that it's not just words in PowerPoint with colorful balloons bursting in the back. We showed you how the system is actually working, come together. What you actually saw wasn't a live system. It's not a recorded thing or anything. You can actually try it. It was running on the cloud. And you saw how it expanded, and you were able to do more stuff without one impeding the other. We had to make design assumptions, architectural assumptions, which are about 5 years old, and based on which we put this together. The conversation I had with Mike was almost 4 years old. Some of these principles about workload isolation, having a programming language, multidimensional scaling, all these are the architectural principles on which this system is built. This is a very powerful tool that we have built for you here, and it has been a phenomenal journey working with this team to put this thing together. But what really excites us is what you all, our customers and our partners, build on top of it. What possibilities you imagine which we haven't yet imagined. That's what excites us when we build such systems. So I will request all of you to start your own revolution, which is just a small step. Download this product and try something. And that's available to you now. So you can build those amazing experiences that the world is waiting for and do it in a manner where things are simplified, more streamlined, and where it's a pleasure to do this stuff. We'd love for all of you to have some fun while building this stuff. That's why we work hard enough here to build such systems and bring it to all of you. We really appreciate what many of you do with us, which is already extending and building stuff we haven't yet imagined. With this, the possibilities became exponentially more available to you to innovate in a manner which the next phase of the industrial revolution is waiting for. So looking forward to seeing more exciting stuff from you when I meet all of you in the next Connect. Thank you. Now let me bring up onto the stage our CMO, Peter Finter, to wrap up the morning sessions and give you some perspective of what you just saw and what you should be, what's in store for all of you. Peter.
Thank you very much. Ravi, what a great job this morning. Thank you so much. And as you say, you can make it look easy if you do all the hard work behind the scenes. And the team has been working extremely hard to solve some very challenging problems so that you don't have to solve those problems. You can apply the power of the Couchbase data platform to your own business, to your own situation, and go and make amazing things happen. And that's really what the rest of this day is going to be about. For the next few hours, we will be in 4 separate tracks. We want you to take full advantage of the opportunity to engage with each other and with our engineering leaders as they delve deeper into the capabilities that are available to you. We've orchestrated these tracks deliberately to hopefully reflect your own areas of interest and focus. Architects, please take the track around architecting the data platform. We have a specific developer track for developing with agility and how we can leverage the power of the platform to quickly and easily create these amazing new applications. For those with an operational bent, deployment at scale is about how we actually bring out this platform to the highest level. As we've seen, businesses running at massive scale, the massively interactive enterprises that depend on Couchbase, how do we make it happen? That's the track for you. And for those who really want to go deeper in the analytics service, this incredibly powerful new capability that we're introducing today, a specific track for you. But I do not want you to miss the end of the day keynotes. Scott Anderson will be taking us through our product roadmap, reflecting on how far we've come over the last 12 months. It's been an incredible journey. An amazing amount of innovation has manifested into our platform, but you don't know yet what's coming next, and we want to share that with you at end of day today. So please come back for that, followed by a technical panel which will be featuring this rather special guest of ours, known as the father of SQL, Don Chamberlain. We are privileged to have him with us to talk about this next step of the journey from SQL to SQL++ and even beyond. So with that said, enjoy the rest of your day, and we look forward to seeing you back in here at 4:40 this afternoon. Have a great day. Thank you.